Okay, so let's take a look on how we offset where the bullets are moving to. So if we go to the script of the bullet right now, we're going to see that its start method is going to set the direction where it's going to move. So that's going to be vector3.forward. So it always goes to the same direction. But what if we want to change this direction? And better yet, what if we want to make something else to be responsible where the bullet's going to be aimed to? Okay, so this can be easily done when we spawn a prefab. Okay, when you create a script for the bullet and you generate a prefab, it doesn't mean it's never going to be modified again. Okay, it's not a closed box. You can normally, as it was a normal game object, in fact it is just a game object, you can just access and change its properties. So this is what we can do. In the bullet, we can make a new variable here. We're going to type public vector3 shooting direction. Okay, and let's not initialize it with anything. And here where we say add force, we're going to replace this forward vector3.forward direction to shooting direction. Okay, so right now shooting direction is just a vector3 that is going to be 0, 0, 0, as this is the default here. So we have to change this. Okay, we need to make a few adjustments to that. So now the player is the one responsible for changing where the bullet prefab is going to. Okay, so right now we just instantiate it, but we don't modify anything on it. So we need to learn how to do this. And what we can do is this instantiate method not only instantiates an instance of this bullet prefab, but it also returns what we just added. Okay, so if you hover your mouse on instantiate, you're going to see that it's not a void method like start or update. It's a game object method. It returns one. So here we're going to type game object bullet object equals to instantiate. Okay, so that means we access the bullet's game object. But notice something. One thing is the bullet object, and another is the bullet component. Okay, the bullet's component is what we can actually use to change the shooting direction or the shooting force if we want. Okay, this can be easily done. But now in the player, what do we need to do to access the bullet's component? We're going to do something very similar to what we did to find the bullet's rigid body. We're going to use this getComponent method call. So here in the player, we're going to type bullet with uppercase B, as this is the class, and then bullet lowercase b, as this is going to be the variable name, equals to bullet object dot get component of type bullet, which is exactly what we want. We want to access the bullet component. And now if we type here bullet dot shooting direction equals to vector3 dot forward, we should have the same effect in what we did right now. Okay, we're going to save that vector. Okay, let's save the script, wait for the compilation, press the play button, and now once we click, it behaves the exact same way as it was before. Okay, but now we have the freedom to use the player to define where the bullets are going to be shot to. Okay, so this is what we can do. Instead of using vector3.forward here, we can define our own vector. Okay, if you take a look on the player, okay, and if you consider this to be vector3.forward, okay, it just points there. This works as a direction, and there is an essential difference between what is a point and what is a direction. Both of these things, they are represented by the structure vector3, which is it's consisted of the x value, the y value, and the z value. Okay. However, if you want to move to other directions, you have to change that. It's like you are rotating this camera to make this blue arrow to point at other directions. Okay, and there are plenty of ways to do this, but still, the thing is, this direction here is a vector3 of size 1. Okay, imagine it's just an arrow, and this arrow contains, its size is basically 1 unit. So whenever we are dealing with directions, we need to be very careful that we're going to use something that contains the size of 1. Okay, because since we're going to multiply this direction with a certain value to scale the force that is going to be applied, the calculations are going to be executed correctly. You might have some weird issues if you don't adjust the vector to have the size of 1. Okay, sometimes it seems like we're pointing to a certain direction, but then the bullet would move a bit more to the left or to the right. Okay, so just to make sure we don't have any problems with calculations and rounding operations and things like that, we need to make sure that the vector is size 1. And to do this, we're going to run an operation called normalization. Okay, so here, where we define vector3.forward, let's type new vector3. Okay, so this is the constructor for the vector3 structure. So we can build a new vector. Okay, let's start by typing 0, 0, and 1. Okay, so we build a new vector that is basically the same result as vector3.forward. It's a vector that points forward. But if we want to make the bullet to move a bit to the left, we could change this to something like 0.3f, for example. And if we want to make it move a bit up, we can change this to 0.2f, for instance. Okay, but the important thing is, this is not a normalized vector, so we can't change this shooting direction just yet. So instead of setting it right now, we're going to type vector3 shooting direction equals to that. Okay, so we built the vector here. And now we can type bullet dot shooting direction equals to shooting direction, which is this one we defined here, dot normalized. So if you see the summary of this normalized property is going to be saying returns this vector with a magnitude of 1. Okay, so it's going to be in the exact size that we want. And now we save this, we go to Unity. Now let's wait for this compilation to complete. And now we're going to press the play button. So the camera is here, we're clicking, and notice that the bullet is going to the top right, okay, because we changed the direction where we are shooting these bullets, okay? Now that we have this, let's make this a bit more interesting, okay? We already see that 3 and 2 are values that are too big, okay? The bullets are kind of going away from the wall. So we want to use random numbers here. Let's type random.range. And between parentheses, we have to set the minimum value and the maximum value. So we type minus 0.15f and positive 0.15f. Okay, so this is going to return a random number from minus 0.15 to positive 0.15. It could be 0, 0.1, minus 0.1, and other values. We do the same thing for the vertical value as well. So we're going to type random.range. Then let's use minus 0.1f and positive 0.1f. Okay, so it should have a random direction every time we shoot. So now let's save this. We go to Unity. Let's wait once more for this compilation to complete. And now we press the play button. And once we do this, if we click, we shoot the bullet in different directions all the time. Okay, so this is kind of interesting. Okay, it's like we are testing the shooting of some tennis balls in a wall. And as you might have noticed, we have some infinite balls in here. They're not going to disappear. So to fix this, let's add some little lifetime logic for the bullet. So we're going to open the bullet script, and we're going to declare a variable here that is going to say public float lifetime. And let's set this 3f, so the bullets are going to last for 3 seconds. Now we declare the update method back here because we deleted that before. And now we're going to type lifetime minus equals time.delta time. So this is going to count down from 3 to 0, okay, and this works because we are in the update method. And we're going to type if lifetime is lesser than 0, it's time to destroy the bullet, okay, actually lesser or equal than 0. And to destroy, we're simply going to type destroy and pass game object as a parameter. So we save this, we go back to Unity. And after this compilation is complete, we're going to press the play button, and we can shoot as many bullets as we want, but after 3 seconds, each of them are going to disappear. Okay, so this should be it for this video. In the next one, let's make another effect with prefabs when the bullets hit the wall.